Hello, today's date is 8. I will never fill that in because multiple classes are actually using these videos. Our learning target today is to solve equations with variables on both sides. I'll pause the video here to make sure that you have the date and the learning target written down. Our first example is 15 minus 2x equals negative 7x. And you remember yesterday we were talking about one of the first things that we wanted to do was to combine like terms. So this is really where we want to combine like terms, but they're not on the same side of the equation, so we can't just combine them. But we can use the properties of equality to combine them onto the same side. So I look at these two variables and I want the variables on one side and the constants on the other. So I'm going to leave this 15 here. I want to move the negative 2x over to the other side. So I'm going to add 2x to both sides. What allows me to do this, whether I'm just adding a number or I'm adding a term that has a variable, is this is called the addition property of equality. And you've been using the addition property of equality, we just haven't named it. So then on this side I am left with just 15, and on this side I have negative 5x. And now I can just go ahead and solve it because I have my constants on one side, my variables on the other. So I'm going to divide by negative 5. What allows me to do that is the division property of equality. Sometimes you're going to be asked, especially when you get to geometry next year, you're going to be asked what properties allow you to do certain things. So this is the division property of equality. So I now have x equals negative 3. I'm not done yet. I want to check. And again, I want to check with my very first equation. So I'm going back to the beginning. I've got 15 minus 2 times negative 3 equals negative 7 times negative 3. So I've got 15 plus 6 equals 21. And 21 does equal 21. And for the first time, we're actually having to simplify on both sides of the equation because we had a variable on both sides. So again, we want to do that check. I'm going to give you a practice problem now. So here's your practice problem. When you are done solving that and finding what x is, please make sure that you do a check and then enter your answer in the play pause it and click continue. On that problem, you should have found that x equals negative 3. Notice please on this problem that I used the subtraction property of equality when I subtracted 5x from both sides, and I used the division property of equality when I divided by negative 8. I am not going to ask you to write these out by the side, but if I ask you what property allows you to do that, you should be able to tell me, and it's obviously just whatever operation I'm doing, property of equality. And again, I should check. Our next example also includes the distributive property, which we practiced a little bit yesterday. So that should be pretty straightforward. Again, we're multiplying the term, the number out in front by both of these terms. So 3 times 5x is 15x, 3 times 2 is 6, and that equals 15x. I notice that I have variables on both sides, so my goal is to get them to the same side. Get the variables on one side, get the constants on the other. So I'm going to subtract 15x from here and 15x from here, and I end up with 6 equals 0. So my question of you is, does 6 equal 0? Can it ever equal 0? So when I'm doing this and I have variables on both sides, and I end up with a statement that is not true, 6 does not equal 0, we say that this equation has no solution, because there is no value for x that is ever going to make that equation true. So I don't need to check, because there's nothing for me to check in that example. I just say that there's no solution. Example number 3 is going to be another twist, but a little bit different. So let's use, for example, number 3, negative 2 times 4y plus 1 equals negative 8y minus 2. So again, I'm going to distribute. So I've got negative 2 times 4y is negative 8y. Negative 2 times 1 is negative 2. And that equals negative 8y minus 2. I'm going to collect my variables on the same side. So I'm going to add 8y to get rid of it here. Again, I'm using the addition property of equality. And I end up with negative 2 equals, okay, well, this goes away. So negative 2 equals negative 2. Is that true? Yes. And is it always true? Does negative 2 always equal negative 2? Yes. So when I have a situation where I've solved the equation and I end up, my variables actually went away, and all I'm left with is negative 2 equals negative true. This is called infinitely many solutions. Or sometimes we just say infinite solutions. So when I end up with a statement that never could be true, I have no solution. It's always true, I have infinite solutions. I want to do one more example here, and then I'm going to give you a couple practice problems. On example number 4, I'm actually going to draw a rectangle and label one dimension 8 and another dimension 2x. And I'm going to tell you that the perimeter of this rectangle is equal to the area. And I'm going to ask you to write an equation and solve for x. So notice I'm going to use math symbols now to write what I just told you. So the perimeter of the rectangle is equal to the area. So now we have to use some of our background knowledge and ask ourselves, well, how would I find the perimeter? So I know that the perimeter is the distance around the outside. So it's going to be 2x plus 2x plus 8 plus 8. So that's all four sides of the rectangle. And I told you that that equal to the area. And I know to find the area, I'm going to multiply 8 times 2x. When I give you a problem like this and I ask you to start by writing an equation that models the situation, I would like to see the numbers from the situation in your equation. So I know that you could have added this together and said 4x plus 16 equals 16x. I know that these numbers are easy enough for you to do that. They won't always be that easy, and I want you to get into the habit of whatever numbers are over here, I want to see those numbers in your equation. Then you can simplify. So then I've got 4x plus 16. I'm combining like terms equals 16x. When I'm adding like terms, I just add the coefficients because I have two x's, I have two groups of x, and I have another two groups of x, so I have four groups of x. But when I'm multiplying a number times something with a variable, I can multiply first the 8 times, this is really 8 times 2 times x, and I know that because multiplication is commutative, that I can actually multiply those in any order. So I'm going to multiply 8 times 2, and that gives me the 16, and then x. That's just a quick review of what you've already learned about combining like terms and multiplying with variables. So once I have that equation, now I can collect my like terms on one side. I'm actually going to subtract 4x from both sides so that the x's are over here and the constants are over here. So minus 4x. So I've got 16 equals 12x. And then I'm going to divide both sides by 12. So x equals, now you can do 16 divided by 12 right here, but I would go back to my understanding that every fraction is a division problem, every division problem is a fraction. So I can actually also just reduce this. So if I reduce it by a factor of 2, I've got 8 sixths, and then I'm going to reduce it by another factor of 2, and I've got 4 thirds. So in this case, x is going to equal 4 thirds. I've never even done a division problem. I have just simplified my fraction. Starting now, unless there is a reason for you to change an improper number into a mixed number, you can leave it as an improper fraction. So much of the work that we will be doing, it is easier to work with and it makes more sense to work with these numbers as improper fractions rather than mixed numbers. So you can leave this as 4 thirds. And again, I'm going to go from there over to here. I'm going to go back to my original equation and check it. So I'm going to be writing the equation exactly as it was at the beginning. And then I'm simplifying both sides. Sorry, I didn't space that very well. So 2 times 4 thirds is going to be 8 thirds plus 8 thirds plus 8. Actually, I'm going to go ahead and simplify it. 8 plus 8 right now is 16. And then over here I've got 16 times 4 thirds. 8 thirds plus 8 thirds is going to be 16 thirds plus 16 equals 16 times 4 is 64 over 3. I'm going to change this 16. I don't like how this problem turned out. Sorry, I made it up right before I wrote it down and I am not happy with it, but I'm not afraid of fractions. So 16, I'm going to change that into 48 over 3. And then 16 plus 48 is 64 thirds and 64 thirds. I'll make sure the practice problems I give you don't have weird fractions like that. So I've given you 3 different sample problems to think about, and now I'm going to give you 3 practice problems. All right, here are your 3 practice problems. I'm going to ask you to copy them down, work them, put the answers in the play closet, and then check back for the answers. Alright, here are answers for practice problems 2, 3, and 4. I'm going to pause the video for you to check your work, make any corrections to your notes, and then there will be just a quick summary after you continue the video. Alright, our final little wrap-up. I've just written out a summary of what we've discussed today and added a couple things on. So the steps, if you're solving an equation with variables on both sides. First, distribute if you need to distribute. Second, combine like terms if you can on each side. So none of the examples that we did today had anything that you needed to combine on each side individually, but that's what we practiced yesterday. After that, collect the variables on one side and the constant terms on the other, solve, and then check. And then just a reminder that you are using what's called the properties of equality when you're solving equations. And you've got the addition property of equality, subtraction, multiplication, and division. All right, you have some practice problems or some practice sheet to now do. So good luck and have fun.